Welcome to the fourth installment of our bot series. We are trying to understand this time not just what can we do with chatbots, but what is a way that we can direct our own learning personally, and what are some strategies for dealing with these problems of authority. Who is it that you actually trust? How can you actually get to the bottom of that information? So we're going to look at a little bit of some interrogation techniques and to apply them here. So welcome to the Lit Media Workshop. Stay tuned and let's get ready to learn. Today we're talking about learning. That is personal learning, how you can actually know whether you're learning something and evaluating that information, as well as steering. Now here, steering refers to something like driving a car. For example, you might be starting a road trip, and you might be starting from over here, and it's actually very possible that the person who's driving the car, they want to go over here, but you actually want them to go down there. So you have to tell them right here where you actually want to go. And basically, when chatbots, when they do things, they are picking just the most obvious, just the most well-traveled piece of road, which might not be the road you want to travel to. So let's think about some of these concepts that we can play around with. And what are we doing again? Well, we talked about the four shins, right? We talked about information. Information is just things that you're trying to figure out. These are mostly like facts, like what time is it, or who are historical figures from a certain period of time. We also looked at conversation. This is like simulating a back and forth conversation, maybe to learn things, maybe just to have fun, maybe to simulate something that you're doing with a chatbot. Chat, conversation, they kind of work well together. Then we also talked about conversion. This helps you get the information and the kind of thing that you want it to be. This might include summarizing things, taking them from a whole bunch of information into just a little bit of bite-sized information. It might include things like generating particular tables that you need to have generated that compare the things that you want to compare, things like that. And then finally, a generation. This is things like creating poems, making something that hasn't been made before. These are all things that chatbots have more or less been designed to do and do fairly well, depending on what your actual need is at the moment. But all of these things, they all have their limitations, right? We talked a little bit about those limitations, and today we're going to be talking about something that is actually a little bit more in depth. So something that almost combines all of these things together deeply, and that thing is called learning. And learning is actually sort of a creative act. I'm just going to say that. Let's take a look at what I mean by that. Well, this article is probably good enough. This is the 4C model of creativity. This is by Coffin and Bagetto. Basically, all of the different types of creativity can add up to something that is amazing and stupendous, which would be more of a big C level of creativity. This is someone like Feynman or Einstein. They might have a big C level of creativity on a particular thing. There's also pro C creativity. This would be something that might not be a brand new invention, but it might be like a new album by a very professional artist. And then we have a slightly lesser kind of creativity called little c creativity. This is where you're sharing something with your friends. Maybe you're making like a creative meal. Maybe you've made like another different kind of drink out of coffee and milk and caramel and cream. And then we have the mini C level of creativity. This is one that we feel a lot when we have like an aha moment, only it's kind of a huh moment. And that's where you might learn something like Pluto used to be a planet. That could be like, oh, wow, it kind of used to be a planet and it's not because it's a little bit tilted. And so it's not really something that has to be brand new. It's just something that has to be new to you, something that you haven't quite seen before. And how do we get there? What is a good way to actually get there? Well, it's probably not by just asking a tiny question and then reading a lot. Probably, um, probably education has a lot to do with your own personal current knowledge. And this has been talked about by Vygotsky, who talks about this whole principle of zone of proximal development. What does that mean? Well, that means there's this stuff in the middle. These are the things that you can do, the things that you already know. Maybe you know that Mars is a planet. You don't know that Jupiter's a planet yet, or that Pluto's a planet. Maybe you have an idea of what an orbit is, and as you go a little bit farther out there, the information is somewhat understandable to you. If there's things that you actually can't do, even if you tried them, for example, if I tried to teach most of my students in my class tensor calculus, they probably wouldn't get it. It would probably take a very long time for me to build the stepping stones in order to get there. But you might be able to get the idea of some other step that kind of has the same flavor as that, like the Riemann sum, if you're interested. Now, in the middle here, this is like the sweet spot. And in psychology, in computers, and just about everything, there is typically this sweet spot between ridiculously easy and ridiculously hard. And if you can stay in that sweet spot, then that's where you're actually going to be learning the most. Now, this makes it a little bit tricky because those sweet spots are different for different people, which makes trying to give everyone the same kind of education a little bit difficult. But actually, things like chatbots, they might be a very good way to kind of, for you to be able to drive your own educational development. And typically, the information, if you're looking it up, is on the level of, say, something you might look up on Wikipedia. It can be pretty accurate information. But let's think about this in terms of chatbots now, right? Let's imagine this says chatbot can do unaided, and chatbot cannot do at all. Well, this sweet spot is probably where you're going to get the most value out of that chatbot. Now, your chatbot, there's going to be a lot of things it won't know. It won't know a lot of the context around you, like how many cups are in my room right now. I hope the chatbot does not know that. Or what is like my particular genealogy? It probably is not going to know that. And if it doesn't know that, it might actually just make something up. So ask it questions you think might be reasonable for it to know. Other things that it actually can't do is likely things that have not been invented yet, something that it has never read before. Remember that the way that these chatbots work is that these chatbots, they look at all of the data, and then they ingest it, and then they're able to spit it out in creative ways that are tuned to be basically what people actually want from them. So this includes information that would be like from the internet, right? And we know people on the internet, they do lie sometimes, right? People on the internet, they do lie sometimes. So it might be from the internet, it might be from books, it might be from the news. There's all of these different sources of information. And as we learned last time, garbage in, garbage out. If the internet is not giving it the right information, it will not give you the right information. So how do you know? How do you know if someone is telling you the truth? Let's look at a couple of human examples here. One way to get the right information from somebody to know if they're talking about the truth is to take like a good cop, bad cop approach. And in this approach, also called the Mutt and Jeff technique, you have two people in a room interrogating one other person, and one of the cops takes on a role. They take on a very friendly personality. Hey man, I really want to help you out here. And so I need you to help me out too. And the other cop says, hey, I don't even care. You can do whatever you want. I already know that you're a bad guy and you're going to tell me this stuff, because if you don't, then I'm going to put you in prison or jail or whatever for a very long time. And so in this way, having two flavors, one bad cop that's aggressive and negative, and one cop that is good and sympathetic. Sometimes you can draw things out of people that they don't necessarily want to share. Um, you could also think of this as a carrot and a stick technique, where with the carrot you're feeding an animal, and with the stick you're hitting them, like a donkey or whatever. I don't know if chatbots work exactly this way, but I feel like if you take on that kind of authority and how you're talking to them, you can let them know about what kind of information you're actually trying to draw from that chatbot. Remember, the chatbot is kind of unfeeling, right? They are just robots. So while they kind of react in text and may show some kind of emotion, they're just kind of nuts and bolts on the inside. Now, that's one way that you can get good information. There's another issue here, and it has to do with basically one of those it's kind of a logical fallacy called an argument from authority. And basically here it's when somebody just says, I'm going to trust the scientist or the politician or some kind of a religious leader, and just assume that they're correct because they have a lot of credentials or they're arguing from authority. I don't remember if we've talked about this before. We have talked about the rhetorical context, but there's another kind of rhetorical context that talks about how people argue for things. And it's called the rhetorical triangle. I'll link this in the post here. But basically, in this way, we have three different components of a triangle. We have logos, which is like the reason or the actual text that's included there. So this is logic, like I blew out the candle, therefore the candle is no longer on fire. That would be like a very logical argument. And then we have ethos. That's like how actually credible someone is. This is like I'm a candle scientist, and I say that the candle's off because I see it and I just know, based on my experience, that it's off. And then there's pathos, which is based on the beliefs, based on values, based on the audience. And that may be something like, it's nighttime and everybody knows that in our family, we don't have candles on at nighttime. And it would make me feel bad if the candle was on. And so let's just say that it's off. That would be an example there. And these things kind of happen as subtext. They're underneath the arguments that you typically see. And if you've seen something, even like a Marvel movie, these kinds of arguments are going to be present. These components of arguments are going to be present. Now, I didn't mention this before, but really, we just want to stay in the zone. When you're learning about something, you don't want it to be too difficult. You don't want it to be too easy. You want something that's kind of in the middle. And that is basically this idea of flow by Csikszentmihalyi. That's how you say this. I've heard people say it that way. And if you're actually in that flow state, it's kind of an experience, right? It feels really good. It feels like you're playing a video game, and it's kind of where your brain wants to be. And if it's not there, well, either you'll find something easier to do, which might be just procrastinating, or you'll find something harder to do, which might be doing some other kind of task that's not actually the task that you're supposed to be working on. So let's review some of these ideas that we have looked at so far. There is one more idea we need to look at here. And this has to do with the fundamental limitations of the human brain. And this is the idea of chunks. We may have covered this a little bit, but I want to cover this in the context of learning. Great. So, what is a chunk? You might have heard this thing said that makes a little bit of sense, where people can only remember up to 7 things at a time. This refers to the short-term memory in somebody's head, and these are different depending on different people and what they actually do. And so, really, when we're talking about information and we're talking about how the brain works, it has a lot to do with your previous experience. If you're a chess player, then an actual move might be less information to you because you've seen it before. If you're trying to follow a story, let's say that you're watching an anime, and you just go in mid-season, you don't know any of the players. This can be like a very difficult thing to follow. But if you know the different things in the different things that your brain can remind you of, then it's actually much, much easier. So they did a bunch of experiments on people and their assessments of things. He comes up with this thing called subitizing, or maybe if you're remembering a particular number, you try to remember it instead as like three-digit numbers instead of 9 single-digit numbers. And so that's basically some of the information that they did. And the tricky thing is that you actually have to. It's very difficult to study because, again, it's personally dependent and it's also context dependent. And if you give people random-looking information, for example, if you give somebody a word to memorize, they can memorize that word. But if you give them the same number of random letters, they can't memorize it because your brain stores things in concepts and not pixels. And actually, your brain can't even really perceive pixels or individual letters. It can't look at very many of them. But if you try to remember like a sentence and the sentence makes sense, it's much, much easier to remember. Why does this matter? It matters because it changes what makes information easier to learn and memorize. So if you have a unit that is correct, then you will be in this zone of proximal development. You will be in this zone. But if you have a unit that's too big to try to perceive or memorize, it's going to be much, much more difficult for you. Okay, so let's summarize and relate some of these concepts that we've learned, and then I'm going to tell you about some techniques for maximizing the amount of learning that you can do and for steering and evaluating chatbots and the information that they output. Okay, so we have learned things like the proximal zone of development. That is, you have these little circles, and there's this sweet spot where you are learning some information, and the outside of that sweet spot, it's really difficult to learn that information. We also learned about chunking, right? This is like the 7 plus or minus 2. This means that our human cognition is limited. We can only think about so many things at the same time. And as we learn more things, then we can actually increase the apparent number of things we can keep in our head at the same time. We also learned about this psychological flow. And this flow state, basically, if you are learning something that's too difficult, right? We have like easy. Basically, if something is like, we have easy, we have hard, and then we have like fun, let's call it. And if something is too easy, it's not very fun. And then it gets kind of fun when it's kind of medium easy. And then when it's hard, it gets not easy anymore. And so you want to stay over here, sort of in that middle part. Then we also learned about arguments from authority, where if somebody says, hey, I'm a cop, and so you have to listen to me, or I am some kind of authority, and they don't present any kind of argument or facts or anything for you to verify, it's not really a valid argument. So in that case, it would be too unbalanced on just one of these corners of the rhetorical triangle. Then we have this good cop, bad cop. This is kind of as a stand-in for the idea that you really should be scrutinizing, at least in your head, anything that anybody says, especially if it seems like there could be some kind of agenda behind it, or it's a subject that isn't real, that has a lot of controversy associated with it. So let's think about some way that we can apply these And I want to give you a couple of tools for mitigating these issues. And the first thing I want to talk about is additional context that helps the large language model, the chatbot, understand at what level it should be talking to you. So let's try a couple of examples for that and play around with some definitions of, let's go with the planets, since we were looking at all of the different types of creativity. So let's think about learning about the planets in the context of using a chatbot. And let's talk a little bit more about steering, right? Now, there's a lot of different ways that you might want to think about learning about the planets. And so let's think about just a couple of different contexts. And we can even ask the chatbot to simulate these, okay? So let's say that you're trying to explain something to a 6-year-old. Then let's assume that you're trying to explain something to a 25-year-old quantum physicist. Let's just say smart. Now, of course, the ways that you're going to explain these are going to be different. And then let's also dive into one of the particulars of the planet, and we'll just kind of see how that arrives based on the stimuli that the chatbot creates for us. So we will start right here. So we're going to try this out live here. Please explain what planets are. Let's stay to one paragraph only. Assume your audience is a 6-year-old who knows almost nothing about space. And then it's going to start thinking. It's going to answer. A planet's like a giant round ball made of a gas that lives in space. You can think of it as neighbor to our home. Huge circle, bright hot star called the sun, giant invisible racetrack. Oh, I love racetracks. I'm 6 years old. They are much bigger than the moon, but smaller than the sun, and they don't make their own light like stars do. Instead, they stay bright by catching the light from the sun. There are 8 of these big friends in our neighborhood. Some with pretty rings and others with mini moons, all spinning and wandering around the dark sky. So, I think that's pretty good. I kind of think the language is too much. And so I'm going to pretend as my 6-year-old, I'm going to say, my 6-year-old says those words are too big. So let's see if it can dumb down the language a little bit. Think of a planet as a giant round ball that floats in the sky. Our home, Earth, is one of those balls. And the planet stays in a big circle around the sun, just like kids playing a game of Ring Around the Rosie. Some planets are made of hard rock you can stand on, and others are made of puffy clouds. That's Jupiter. I know that. They don't glow like light bulbs. They just stay bright by catching the light from the sun. There are 8 of them in a space family, and they have their own special place in the dark sky. Okay, so sometimes a kid reading this, it's going to make much more sense to them than a kid reading this. It's got other words like invisible, which maybe the kid doesn't know. It makes some illusion of wandering, which to me, wandering stars, the zodiacs, the planets that don't go along with the other constellations. It's a little bit lost because I don't think a 6-year-old is going to really catch on to that subtlety. So there's a lot of issues I would have with basically any of this writing, but it's kind of nice, right? And then it kind of gives you some options. Want to learn more? You could learn about the sun. You could learn about Mars. You could learn about Saturn. And so let's see how this goes if we change the context and we ask for an explanation that might be a little bit more, we'll call it cerebral, more for a person's brain. So we're going to keep things pretty much the same. I've just changed who the audience is. They're 25. They have a PhD in quantum physics, and they haven't studied much about space. So let's see what the explanation looks like instead. So after it thinks, An astrophysics term, a planet is a non-fused or gravitationally dominant body that has achieved hydrostatic equilibrium, the point of where gravity overcomes the internal and body forces to assume a nearly spherical shape. Unlike stars, planets lack the requisite mass of whatever to initiate the thermonuclear fusion of deuterium in their cores. They typically originate with protoplanetary disk through the accretion of dust and gas around a stellar host. So definitely we've gotten some different words here, right? We have accretion, which means to just add a lot to small amounts over time. We have some information that I'm not totally sure I understand. Hydrostatic equilibrium, I understand equilibrium, but hydrostatic, I assume that's like water that is not moving around, but I don't actually know. And then it talks about a scholarly body that defines what a planet actually is. And so we could steer this into particular places. I mentioned that Pluto is no longer a planet. So I'm going to ask if this particular organization had anything to do with that. Let's see. It's not a planet anymore. Did that organization have anything to do with it? Yes. Oh, look, I got it right. I didn't even know that. So they had something to do with it until this amount. The definition of a different object in the belt appeared larger than Pluto. So basically, it's giving me this information, and we're not really going to read all of this information, but we are going to kind of sample it, right? To say, okay, if you wanted to know more about a particular topic, you can drill down more. So there's a hydrostatic equilibrium. So Pluto has sufficient mass gravity to be nearly spherical. And so at this point, I think it would be kind of fun to try to take a good cop, bad cop approach to looking at this here. So there's a continuing controversy. That means it's a good candidate for falsehoods. And so maybe we can figure out what that is. Do you want to know more about the specific mathematical threshold to determine if an object has cleared its neighborhood? Not really. Let's see here. So it says that one of the reason is the orbital path is surrounded by thousands of other icy bodies. So let me think here for a second. So at this point, I think we can just push back on this particular statement. And we're going to be really aggressive in how we talk to the chatbot. And hopefully that will get it to do something interesting. And we'll just see what happens. So I'm going to kind of skip back and forth and summarize based on my responses what the chatbot is saying. Maybe I'll even include this conversation as link in the YouTube. We'll see. So my first information to kind of throw it off a little bit here is to basically call into question that we even know that there's thousands of ice bodies. So I'm quoting it and I'm seeing if it says something interesting that defends itself. And so the basic answer here, for one, it tries to relate the information about quantum physics to astrophysics. So it's saying, hey, these methods are actually kind of close to your methods. And so that's why it can be a good idea to give a chatbot a little extra context about yourself, because it might be helpful in how it displays that information. It also talks about a couple of different techniques that they use. And so I'm going to try to call into question some of the other stuff it has. So stellar occultations. Basically that means if there's stars that get blocked by things, that we can see it. So I'm gonna push back on that now. So my attempt here, I'm basically calling into question that you can even see stars blinking. I'm picking what I see as maybe the weakest argument that has to do with these stellar occultations, and I'm making up an article that doesn't exist. And they say, hey, it's a very reasonable scientific skepticism. Maybe. Talks about how they handle noise when one thing hides another thing. It's a coincidence counting problem, dual telescope verification, differential pattern analysis, the Pluto is clear argument. Oh, it thinks that it actually found the archive paper that I'm talking about that I actually just made up in my head. Let's see if that actually exists, because I have no idea. This is not my field of study. So this is the paper that they're stating here, right? And this is called Quantitative Criteria for Defining Planets. and it's talking about the actual definition based on this same body of organization. Archive is like it's kind of like almost a science journal place. I won't explain it now, but if you have more questions, you can let me know. And so what I really want to know here is what the actual claim is. So their summary of this paper from Google's large language model version of ChatGPT called Gemini is basically not even Earth or Jupiter is a totally empty orbit. Valid. And it's comparing mass to mass. So it's saying, okay, all right, here. All right, fine, you win. Here's an actual article that describes it. And this paper, it's actually not very well cited at this point. If we look at it in Google Scholar, it says it's been cited by 6 people. So it's very new. It's very, very, I think there are probably maybe 30 people in the world who have read this paper. Maybe 50 people in the world who have read this paper. So it's pretty impressive that it got anything that's even close to relevant to that. And here's all of their arguments about why Pluto maybe should actually be considered a planet and talking about that. So let's just look at the conclusion here. Perfection is not attainable in the context of planetary nomenclature. We argue that the physically motivated thresholds, even if imperfect, are superior to definitional voids or ambiguities. They're saying, hey, if we just look at it, it kind of seems like a planet to us, and I think that makes more sense because your math is bogus. That's what this is saying. So let's just, instead of doing the work ourselves, let's just ask for a good cop, bad cop. Let's get a simple table with good cop, bad cop for Pluto as a planet. And so hopefully it just really does this nice and short, but we may have to steer it a little bit more. And so, yeah, so we have a good cop, we have a bad cop, it's listing all of these things, and it is so much work to actually read this stuff. So I'm not going to read it today for the sake of time. It looks like we are about 32 minutes at this point. So instead, I'm going to propose some techniques that you can do for this steering, for this understanding, and even let's do one right now, right? So one of the nice techniques is you can say, please summarize this chat in a very short list. We can try to get a summary here, right? So I'm going to check my notes here for what my thoughts were. Okay, so these are some of my notes on what I think is a nice way for talking about how you can steer your learning and just overall techniques for making this a nice process where you can learn the most and you can make a chatbot actually kind of prove what it's trying to do, right? One thing is you can tell it to say, let's take this step by step. If it's something that's very complex, sometimes taking it step by step allows you to see where the misunderstanding is. This is similar to showing your work in mathematics, where you might be looking at something like an algebra problem where you think you did everything totally correct, but it ends up you just made a tiny mistake someplace. Chasing down original sources. So where did the information actually come from for defining what a planet was? Well, we kind of found that, right? And sometimes the best way to actually know whether something is true or not is to find the oldest source or the first source that you can that actually has the closest eyeballs on whatever the thing is you're looking at. These sources can include things like science literature, like that archive post, news. Oftentimes the things that come onto chatbots are just a random person on the internet. It's like literally just like somebody on Reddit said it, and so that's what it decides to say. It could come from things like Amazon reviews, not particularly good. And so there's all these problems that come up with that we've talked about before. where you can make up citations. This is a very common one where you can just make up citations. That's why I double checked it when I was talking about that archive post. Circular reporting. Do we know what circular reporting is? It's when you have a newspaper that makes something up, and then another newspaper says what that newspaper said, and then later the same newspaper that made it up before cites the other one that is citing them. And so it's just this big train of things that are all connected together that don't actually have data or good reporting. You can also do summaries of things that you've already talked about before. I just did that. And so let's take a look at the summary that was given to me here. So when I asked, here's a short summary of our discussion. It gives me that short summary. A planet is a non-fusing spherical body. There's a Pluto decision. There's counting methods for these hidden pieces of ice. A little bit of information about this conflict, and a little bit of information about this current research. And so if you're dealing with a particular problem, you're trying to understand it, you keep going back and forth with some kind of a chatbot, it can be very difficult to remember exactly what your problems were, exactly what the chatbot talked about, and so on. And so it's very helpful to say something like I said, which is like, please summarize this chat in a very short list. Super, super helpful sometimes. Then asking it to simplify things into smaller amounts of word or simpler words. We did this when we were talking about the supposed 6-year-old that was trying to figure out what planets were. And we were able to do that pretty effectively. So instead of saying sphere, it said ball. It stopped using the word invisible. These are all pretty positive things. So here's some good questions you can ask yourself or large language models as you're learning. How do you know what you know? What is the basis for your understanding? Is it an appeal to authority? Is there some kind of a logical fallacy? Is it touching all of the shapes there in the rhetorical triangle, including ethos about where the authority of the information comes from, logos, the information that's actually the logic there, or pathos, which is like an emotional or feels right kind of an argument. Is it doing all of that? If not, it might not be a great argument. What is the evidence that supports your claims? If you're making a claim about a candle being on, what is the evidence for that? And then, can you take me through this again, step by step, in as simple sentences as possible? You can ask yourself this, right? If you think you know something, you should be able to explain it very simply and concisely. Otherwise, if it's kind of muddled up in your head, chances are you can learn more about that. Okay. Well, that pretty much concludes what we're going to talk about today. And your homework is going to have to do with actually looking at at something and trying to learn something very deep that you haven't learned before, that you think might not be written in a general book for that. So I'll go over that more in class. And next time, we're going to be going over coding. So how do you code with the large language model? So we'll be looking at a tool called P5JS, which is a fun tool for creating, animated JavaScript-based games or visualizations. And I'm going to talk about something called technical debt, because unfortunately, we actually have to do the work sometimes. So, I hope you enjoyed that.